Welcome to this new tutorial about the basic principles of AutomationML. In this tutorial, I want to demonstrate how the AML ID concept works. Assuming we have an AML property type length, this length now gets an AML ID, a unique semantic identifier that is stable for the rest of the life. This is now published in an AML library space, and this library with property type length is developed by a community that needs this length. After publishing it in the AML library space, now we have different use cases. One use case is that an engineering tool number one here is taking over the AML terminology, is using the AML terminology in their database so they can have direct data exchange by reusing the semantic definitions of that library. This is option number one. Another option is that the engineering tool doesn't change. It keeps its own terminology, but map it to the AML ID. This might be done by tagging the existing terminology within AML ID or by separate equivalence table. Now we consider another use case. We have an engineering tool number two that also uses the own terminology, but has mapped it to the ICCDD terminology. Now the question is, which is leading? Is the AML terminology leading or is the ICCDD terminology leading? It looks like a conflict, but we have solved the conflict. The conflict is solved by adding a semantic reference to the AML property length. This is the concept of AutomationML, that every attribute type can reference external standards. This means if engineering tool 2 receives an AutomationML file that references to the AML property type length, the engineering tool 2 can see that this length is again referenced to the CDD length. It can understand it. And if another engineering tool number 3 is mapped to E-class, we can use a feature of AutomationML that every attribute type can have multiple references to semantic standards outside of AutomationML. In this case, it can also reference an E-class term. We can add an arbitrary number of references to external standards, for instance to the SE units. So this means that the engineering tool number 1, 2, and 3, they can inter-exchange data by AutomationML, by the AML ID concept, even if they do not know the AML ID concept and even if they don't use it. This means the AML ID concept is not a competition. It's not yet another semantic standard. It is able to interconnect semantic standards that are already existing. So in this way, we achieve interoperability between engineering tools which use different semantic standards. To summarize it, the AML ID concept means that each attribute type gets a unique and stable semantic ID. The concept is internet enabled, meaning you can publish those libraries. They can be globally found, investigated, reused, and referenced. The meaning of an attribute can then be automatically explored digitally. If you receive an attribute and you don't know what it means, log into the semantic references. And proprietary models can reference this semantic ID. This means that user-defined terminology remains permitted. We do not force participants to switch to a certain terminology. Double definitions are therefore visible and they are allowed, and they can be interlinked with one another. Duplicates are allowed and they can be found automatically. And wherever there is a business case, the standardization can be initiated to resolve such kind of duplicates. This means the AML ID concept is designed for an evolution, for an organic growth. The base principle of the AML ID concept means that every attribute type that is published gets a unique ID. This ID, for instance, here of my private library here has an ID, and this ID is unique, and once it is published, this ID is a semantic reference. So this means AutomationML library types become referenceable by themselves. So I can distribute and share my libraries and others can use the semantics. And I show you how this works. This library is already published. Now I make a new project with my private library here, my private attribute type lib with my private length. So what I have to do is I have associate the AML ID of the already published attribute type to my private one. I do this by selecting find attribute type online. Then it is searching in this space that I've pre-selected here, and here I can select the language type I want to. Here I select the language type of the latest version that I have published, and I make a semantic reference to that. This finally means that this attribute that is still my private one has now a semantic reference to the AML ID of the already published attribute type. And by clicking on this question mark, I can get an information about this one. Now let's switch back to the already published library. The concept is even more powerful. Imagine that there is already a semantic definition of a length somewhere, for instance in the SE units, or in the E-class library, or in the IEC Common Data Dictionary. Then I can use the AutomationML capabilities of adding a semantic reference of this length type to an IEC CDD or to an E-class or to an SE unit library. This way I can interconnect semantic libraries with one another. And every user of this length type implicitly gets the semantic references to all the other ones. What do we have achieved? With the AML ID concept, we make attribute types globally referenceable. Further, it can map existing semantic standards and can build bridges between them. This simplifies the data exchange between tools that are committed to different semantic standards. We invite standardization organizations to model, publish and share their terminologies to make them globally and digitally referenceable.